What page did 39. 39. This is page 39. Page 39. We are looking at polynomials. You worked with them in middle school and 8th grade, and we are back at it. The test you took yesterday, I'm going to get with a few people who scored poorly, and you're gonna have to remediate. I'm not really sure what's going on with the content that we're learning. Like, I need you to understand that you actually have to know how to do it. It's not one of those where you can just say, well, that was a bad unit, I'll just hopefully never see that again. Not right now. Everything we're doing right now, you're going to see again. So you have to know how to do it. So if you did bad on that test yesterday, and anyone who did bad would know that, you have work to do outside of what we're doing concurrently right now, okay? So you need to keep that in mind, and you need to step up to the plate. All right, we're looking at this paper. You'll notice it's just one side. It's got a one-stop shop, all the information right here. And then at the bottom, there's some examples. Then we'll move to delta math. First, polynomial. That is an expression made from one or more terms that involves constants, variables, and exponents. There's an example of a polynomial right here. The way you read it is x cubed minus 5x squared plus 4. That's a polynomial. Does anyone know what poly means, the prefix? Many. Nomial, name. Many names. So as we are looking at this, or many terms is another way to think of it. As we're looking at polynomials, we're going to learn there's a couple of vocab words associated with them. You have to know the vocab words. So it's kind of like if you don't know it, you're going to have to practice it, okay? Make flashcards or something. The 3 vocab words that we just mentioned that make up a polynomial are term, coefficient, constant, and variables. Variables, you already know, are when it's a letter in the expression, right? And it's called a variable because it varies in value, because numbers get plugged in for x. Y'all know that. Term is parts of an expression. Parts of an expression. If I'm writing, you should be writing. So looking at this example right here, terms are separated by plus and minus signs. So there's a minus sign, there's a plus sign. So how many terms are there? There's 3. It also helps if you draw slashes between the expression. So the first term is x cubed, right? And then I'm going to draw a slash. The next term is, carry the sign with it, negative 5x squared. The next term, draw a slash, is positive 4. Notice I didn't put the plus sign because it's understood positive. So there's 3 terms there, and you identify them based on the signs. The signs separate the terms. Coefficient should ring a bell. A coefficient is the number in front of a variable. The number in front of a variable. So what is the coefficient of x cubed? Well, what's the number in front? In front. There's an understood secret 1 right here. So it's 1. What is the coefficient of x squared? Carry started the sign with it, it'd be -5. It's the number in front, okay? Sign included. Which brings us to constant. Constant is a term that contains only numbers. Actually, it should say only a number, but it's fine. The reason it's called a constant is because it is constantly that value. It never changes because it doesn't have a variable next to it. So what is the constant in here? 4. And it's because there's no variable next to it. What would it constantly be? 4. Next, standard form. Please open your notebook to your hot pink formula sheet. Hot pink formula sheet. I need to see everybody doing this. Hot pink formula sheet. Do you see standard form on there? Standard form. I see one on the left, and then I see one on the right. Which one kind of mirrors what we're looking at right now?
The one on the...
Say right.
Right, yeah, I was going to say it, but then the other one.
The one on the right says ax squared plus bx plus c. What do you notice about the exponents in that formula? What do you notice they do?
They keep going down.
They keep going down. Great observation. That's standard form. Which exponent's in the front? Which one's in the very beginning? If they're going down, it would be the one that's the highest, right? So looking at this right here, standard form is when it's written in alphabetical order, talking about variables, with the highest exponent blank. I don't remember what goes in that blank. Right here it says the highest exponent is called the degree. Oh, I know now. With the highest exponent first. I couldn't think for a second. The highest exponent goes first. That means it's in standard form. And then you're able to answer the question of what's the degree of the polynomial? The degree refers to the highest exponent. So looking at your formula sheet where it says standard form, ax squared plus bx plus c, what's the degree of that formula? What's the highest exponent?
8x squared.
Just the exponent. Read the exponent to me.
Oh, yeah.
Remember the exponents?
Oh, squared.
Yeah, so squared, 2. Okay? Look at this one right here. You can close your notebook now. Come back to this and look at this example. 3x squared plus 2x minus 1 plus 5x to the 4th. Is it in standard form? No, it is not. Standard form would have your highest exponent in the front. We are going to rearrange this so it's in standard form. We're going to write it right here. This is a cup game. Remember the 3 cups? You put the ball under and then you shuffle the cups?
Yes.
We're going to shuffle the terms. First, let's separate the terms so we don't accidentally move a sign that didn't need to be moved. So go to your paper and I want you to draw slashes between the terms right now. Draw slashes between the terms. And now let's see if you did it right. you should have put it right after any variables or numbers. So there's a slash, there's a slash, there's a slash. So how many terms are here? There's 4. Which term belongs in the front? Positive 5x to the 4th. So we're going to write that first. Which term comes next?
3x squared.
And it's positive or negative? So I'm going to put a plus sign. Next, positive 2x, then what? Negative 1. Now, what is, I need you to be with me. You should be doing this. Right here. What is the degree of this polynomial? 5.
Oh, 5x. Positive 5x to the 4th.
The degree is merely the highest exponent. You should only be
4.
reading to me a number.
4.
It's 4.
There we go.
Why?
Tower.
Because it's right here. It's that 4.
The number at the beginning.
It's the exponent of that term in the very front because it's the highest exponent. Now, this is really important. Degree gets used a lot. If I said to you, what is the temperature outside? Obviously, you would tell me the highest degree that it's measuring right now, right? You wouldn't say, well, I don't know, but yesterday it was 30 degrees. That doesn't help me at all, especially in Georgia in the fall, right? You would say it's exactly 68 degrees outside. Why? Because the thermometer is all the way up to 68, no higher. So the degree of a polynomial is a lot like the temperature of the weather. What's the highest exponent of the polynomial? That's your degree. So this is degree 4. What would the degree of this example be? 3. That is degree 3. Yes. All right, now, which brings us to the next couple of vocab words. When we're talking about polynomials, there's 2 different ways to classify them. They can be classified by degree or by simply the number of terms, which means it doesn't really matter what's in it, it's just how many terms there were. Number of terms is as easy as drawing your slashes and then just counting. How many terms was in this example here?
4.
4.
4.
Then that means it would be called a polynomial.
4.
How many terms were in the example at the top of the page? Here.
3.
There were 3.
Not 4.
So that's a trinomial because how many wheels are on a tricycle? 3. How many terms does a binomial have? 2, because bicycle has 2 wheels. Monomial, mono means 1. Mono y mono, 1 on 1. So these prefixes are giving you a clue of it being a monomial, binomial, trinomial, 1, 2, or 3 terms. These are the slash marks, okay? Polynomial is what's used for anything higher. Now, I'm going to give you a Delta Math assignment, and it actually expects you to know degree 4 and degree 5 sometimes. So we're going to write it, but in terms of just common practice, 1, 2, and 3 are the most important. Degrees 4 and up, you usually just say polynomial. Technically, degree 4 is called a, wait, I'm thinking of something. I don't want to put that on there and then confuse you. It's quartic. Yeah. And then 5 is quintic. Quartic's already over here. You're good. We'll worry about that if it comes up. I don't think it actually is quintic. Now, let's look at this. This one's a little different. If the degree, meaning highest exponent, right, is a 0, then it's called a constant function, a constant polynomial, which an example of this, would be the polynomial 3. Is there an x at all? Stay with me. Is there an x here? No. I want you to write this, and then I want you to put x to the 0 power. Put x to the 0 power. That is a constant, because if you go to graph it, it's just going to be a horizontal line. It's just a number, right? This word should look familiar. This word was all the way up here where we were talking about how it's just a number. So those stay the same. That's good. Linear is when it's degree 1. You learned linear functions in 8th grade. Your entire 8th grade math class was linear. Okay? So like x to the 1st power. Quadratic, this is what we're going to learn in 9th grade. Quadratic is when it's degree 2. This is 9th grade, which means this is the most important one. This is where we're going. Preview of what's to come. Cubic is 3, quartic is 4. Those are algebra 2 and higher. So that's junior year. Okay? Degree 3, degree 4. All right. Come over here to number 1. We're going to name it based on the degree and the number of terms using this chart, these charts. So first of all, draw your slash to separate the terms. Also identify your highest exponent. Then I want you to write the words that identify the number of terms and the degree. Everybody should be trying. If you're not participating on something as simple as this, then that is setting the bar super low.
So we're putting these in order.
If it's not in order, no, you're not necessarily putting it in order. There's no room. But you are looking at it carefully to identify.
You're just writing words in?
Yeah, you're just writing words. So number 1, what is the degree here?
Oh, it's a quadratic.
Careful.
It's constant. Oh.
Oh.
It's degree 1, so that means it's a
Linear.
linear.
I was looking at it.
And then how many terms?
It's a binomial.
So it's a linear binomial. Terms is the
Cubic.
slash marks, and then you identify how many there are.
Cubic.
So how many terms are here? And what's the degree?
Cubic.
The degree is 3, right? So this is a cubic trinomial. Now, part of our Delta Math practice will be being able to correctly identify the degree and the name of the polynomial based on the degree and how many terms there are, okay? We're also going to look at adding and subtracting polynomials because you already did this in 8th grade, but they were all linear. Now they might be quadratic or cubic. You may have some cubics in there, but you just have to identify the like terms. To add and subtract polynomials, it is a lot like adding and subtracting radicals. They have to be like terms before you can add them. Okay? You combine like terms. What does it mean to have like terms? It means they have the same variables, could be more than one, and the same exponents. They have to match completely. X squared can only go with X squared. XYZ can only go with XYZ. Alright, adding. Simple enough. You're combining like terms. Yes, these are in parentheses, but notice right here it says, hey, you're just adding them. Okay, a lot of people see parentheses and they start multiplying. Please pay attention. This says add. Now, there's a technique I'm going to show you that when it's a really long problem like this, you can use your pencil and come underneath it and make marks for your different terms. So this, I make the mark numbered lines based on the exponent. The exponent here is 2. I'm going to draw 2 lines. The exponent here is what?
1.
I'm going to draw 1 line. This has no variables, so this is a constant. I'm going to put a C. This one has how many? What's the exponent?
3.
3. This one has
1.
1, and this is a constant. And now I can visually see which ones go together. Also, I can see which one needs to shuffle to the front because it needs to be in standard form.
Okay.
So which one needs to bump to the front?
2y3.
2y
exponent
cubed.
3. Sorry.
2y cubed needs to be up front. Now that one's done. What should come next?
5y2.
And it's positive, so put a plus sign. Next, we need to actually combine our line and line. So we got 7y minus 6y
So you got 1y2.
plus 1y. Check your signs. 7 minus 6. And then we have negative 2 plus 4
2.
plus 2. So that's the expression after you can add. Now, another way you might see it presented is written out as a sentence. Find the sum of 3a squared plus 5a and negative 14a squared minus 5a plus 14. If it's written out like a sentence, first of all, you need to know sum means what? Add. Total, same thing. A second way to write it is you could stack them and line them up under the ones they go with. So 3a squared would line up under which one?
5a or 14.
Negative 14a squared. So I'm going to put plus 3a squared here. And then 5a would go under what?
5a.
Negative 5a. And then now I'm going to draw my line, and I'm going to stack this and add straight down. What's negative 14 plus 3? Negative 11. Don't change the variable. Now, what happens here? Negative 5a plus 5a.
Oh, see? Oh, see.
Negative 5a plus 5a.
Oh, no, 0. It doesn't write anything.
0.
Don't they cancel?
Can't have
Zero.
it.
Is it negative 5 plus 5, 0?
0.
So those are gone, so there's no more a term. And then this has nothing to combine with, so we bring it down.
Why don't the terms combine here? Like the 2.
When you're adding and subtracting, variable expressions and radical expressions don't change. They're like last names. When you're multiplying and dividing is when things change. Every time. And that's the same rule with polynomials and with square roots and cube roots. Adding, subtracting, they have to match, nothing changes. Multiplying, dividing, there are no rules. Everything changes. Okay? Alright. Subtracting. Same concept, you just have to be careful with that negative if it is right in front of a set of parentheses. So where it says distribute the negative, they're talking about right here. Notice this is an understood -1 that is multiplying to everything after it. Okay? So we have to account for that first. Does that change anything up here?
No.
Not at all. So I'm going to bring that down. I'm just going to bring this down unchanged. Now, some of you who don't like to show work, you need to just get off your high horse and start showing work. It might be the difference between you understanding this and making a good grade. Now I'm going to distribute this -1. I'm just multiplying by -1, y'all. What happens when you multiply by -1?
Turns to a negative.
Not always.
Unless
Could
it's
be
positive.
negative, which would change it to a
Positive.
So the best way to say to yourself is it changes the sign. It's a sign change. So this is positive 7x to the 5th. It'll become negative 7x to the 5th. This is positive 2x cubed. It'll become negative. This is negative 3x. It'll become positive 3x. And now you can combine your terms. Now I don't want to go underneath and draw 5 lines and 3 lines and all that because then I won't have room. So try to combine it with your eyes. What's the degree of this polynomial? What's the temperature outside? You would tell me the highest temperature.
Oh, fuck.
It's 5. It's a degree 5.
What's it called?
Technically, it'd be quintic, but you can just say degree 5. All right, so 6x to the 5th minus 7x to the 5th leaves me with
-1.
negative 1x to the 5th. Don't write the 1, y'all. Don't write it.
I wrote the
Delta Math will mark it wrong. Next, which one should I do?
Let's do x.
Cubed, negative x cubed minus 2x cubed,
-3.
negative 3x cubed. X plus 3x,
It's 4x.
4x.
Positive 4x.
That's it. Yeah, we're not solving. Now, this last one, I want to tweak this a little bit to show you something that you're going to see on Delta Math. You're going to see these for sure, but then you're also going to see one that's words. So do your best to write small here. If you don't have enough room, then just write it on the back of your paper and say, see the back. I want you to write this. Watch what I write and see how big you need to write. Subtract negative 6w cubed minus 4w plus 2 from negative 8w cubed plus 4w. I want you to put that there. Now it gets kind of crowded. Please write it. This is important. You're going to see this on the Delta Math and someone's going to get it wrong and you're going to be like, I don't understand how I got this wrong because I did it right. Get it written down. Now, before I explain why that one looks like that, let me tell you a technique in math. I used it all throughout college. I went on to get my master's in math. I even got my specialist in math ed. When I have a math problem in front of me that might be tripping me up, I always bring it down to something simple. Because if I can understand the simple concept, then I should be able to apply it to just ugly numbers. Okay? So ignore all that. And I want you to just think common sense. instead of all of the polynomials, let's just use numbers. Subtract 3 from 2. So the language, subtract this from that, means you're starting with that and you're taking this off, right? Remember, order matters when you're subtracting. So red means wrong here. A lot of people, they say subtract, I see 3, I see 2. So they're like 3 minus 2
No,
is
it's 2
1.
times. You have to take 3 from 2.
But it's saying subtract 3 off of 2, which means you start with 2, you subtract 3, and you end up with -1. So you need to be careful on Delta Math when it says subtract this from that. It's a reversal, okay? Which means, coming back over here, now this one's already set up for you. This is, you can see how I did it. Subtract this from that. And notice you have to put this minus sign, you have to put these in parentheses because you're going to distribute that negative. Okay? So I need everybody right now, just like we did here, I need you to do that here, right now. Great. Those of you that haven't done it, catch up with me. You're distributing the negative and you're showing your work. Does it change anything in the front?
No.
Wait, no, not front. Not front.
Then carefully change the sign of everything in the parentheses after the minus. So this becomes 6W3 cubed. What's this become?
4W
Plus 4W minus 2.
minus 2.
Now I can go in and combine my like terms.
-2W to the -2W cubed plus 8W minus.
Any school. Let's go, Jeremiah.
All right, if you have any questions, you'll raise your hand and I will come answer them. If you understand it, you will keep this paper out and you will now move to Delta Math.
Delta Math, yeah.
I'm going to lock your Chromebook down to Delta Math and Desmos. I don't think you need Desmos. You've got your handheld, but if you need it, raise your hand and I'll open Desmos.